Starting with section 3.2, make sure you have section 3.1 finished or close to finished. Don't worry, I won't count off too many for missed problems, but if you do have questions, make sure you're sending me a message and communicating that with me so I can help you. Starting today with independent events and conditional probability, we're going to talk about the difference between independent versus disjoint, and I'm going to give you a little bit more to play with the equations we talked about in 3.1. I'll bring those up as we go. So at the beginning it says, in part 1, independent events A and B are independent if A and B is the product of A and B. So just understand that while we generically refer to these as event A and B, we could substitute event A and B for, if I flip a coin and get a head and I roll a die and get a 6, what's the probability of getting both? Well, we've learned this to be and means multiply. So if these are independent, if I wanted to know the probability of A and B, I would just multiply those together. The difference between a conditional probability and a regular probability is that the question is first being asked in this first part. So let's look here real quick. The question is actually right here. What's the probability of A? But we have to have B before we can have A. So let's say the probability of A is 50-50, but B doesn't happen. Well, that means you're dividing by 0, and you're not allowed to do that. So if that were the case, it means we can't figure this out. A is not going to happen. It's a prerequisite. It's kind of like you can't go, hanging out with your friends unless you do your homework first. Hanging out with your friends has its own probability if you don't include your homework. But as soon as you put a stipulation or a prerequisite in front of it, that's when it kind of affects it. So over here I have a simple formula. What we're saying is the probability of A and B are both occurring, but then we divide B out because we know that that's only there to make sure A can exist. So in the first part it says the probability of A given B. That's the probability of A and B. And we said that was going to be the product. You can put that here as well, even though the order switches, and we know we're both going to get 0.24 for both of those numerators. And then you want to divide out the given. So here our given is B. So again, the question is really just answered for you. And then this one, the given is A. So remember that first part there, that's the real question. Probability of A and B are really our answers as long as the given condition is satisfied. In example 1, it says let A and B be events such that the probability of A or B is 0.8, probability of A is 0.6, and we want to figure out what is the probability of B. In the first part, it says A and B are independent, which remember means that if I wanted to, I could say that the probability of A and B is the product of each. Okay, I kind of ran out of room. I should put PRA and PRB, but you know what I mean. Okay, now there's an equation we learned in the last section that was looking like this. And since it gave me A or B as 0.8 and A as 0.6, I'm just going to write B from now on. I can figure out the rest by simply saying, okay, well, since this part here is satisfied by taking A times B, I can combine these like terms now, and it doesn't matter that I don't know it, I can find it. Let's see, this would be 1 minus 0.6. And then solving from there, I would want to subtract to get my variable alone, and divide. Cancel, cancel. The probability of B is 0.5. Now, when we have disjoint events, this means they're, like if you were to draw circles, means they're not overlapping, not touching. There is no and. There is no this. So then I would just say, okay, well, they gave me this. That's equal to the sum. right? So that's just a simple plug-in. So if they're disjoint, that means there is no overlap, and therefore this independence idea kind of goes out the window. And it also shows that the probability of B is different by 30% if it's a disjoint versus an independent scenario. For example 2, I've kind of gone ahead and written it out. We already kind of saw this in the boxes above. It's just reiterating how to use your formula for given conditions, and you'll see why in the next example, why it's important to know how to use this formula. But I want to point out before we move on that just because these are the two on the right, it doesn't mean that we can't figure this out as well, or we could figure this or this. The point is if I'm given any two of these three pieces, okay, same over here, I can figure out the third piece. Example 3 is probably the hardest example that we're going to see today. This is a difficult example because with what I'm trying to teach you today, this example actually says that they're not necessarily independent. So everything I just told you kind of is like, okay, well, can I still use that? And this is where we start talking about the difference between independence and conditional rather than independence and disjoint. So you do have this conditional statement here that says probability of A given B. Okay, so that's conditional. And the formula that goes along with that is the probability of A given B equals the probability of A and B over B. This part was given to us as 0.75. The probability of B is actually not given, but we can find it. If you look, it says right here the probability of not B is 0.75. Therefore, the probability of B must be 0.25. Remember, complements should always add up to 100%. So I'm going to go ahead and go back to my equation and put in 0.25. And now I can figure out by solving, this is division, so the opposite of that would be to multiply. The probability of A and B is 0.1875. Now, that's not what the question's asking, but watch this. When you look at this in terms of a diagram, I'll give you just a second if you want to go ahead and write that down. Your probability of A and B is right here in the middle part that we always need to have figured out beforehand. And then that way, let's say you're trying to figure out, okay, well, what's in just A over here? That would be A, which is 0.5, minus what's already there. And we do the same with B. We said that 0.25 was in B. Subtract out what's already there. So in this only B region over here, kind of bled out there a little bit. And then the last thing we need to compute is the margin. So far I have, let's see, 100%. Take away what I have. So that's that guy, and lastly, that guy, and that'll leave me with what I have on the outside, my last region, which is 0.4375. Alright, now that we have all of our pieces labeled, I've kind of cleaned up, so if you want to go see those calculations, just hit rewind. Now that we have all of the pieces, we should be able to answer any questions. So the first one says, let's just write it out. This very simply becomes B and A was the middle, and A was 0.5. There's your first answer. Once you get the picture, everything's much easier. And the second part, now they have a complement here, so watch how I do the complement. It's going to be B and not A. Remember, not A is still a set. Not does not mean not a set. It means the opposite of A. That's really what it should mean. I say not a lot, but opposite's another way to do that. And that will be divided by the second one, which is again my opposite. So if A is 0.5, not A is also 0.5. Not A, 0.5. And then A and B again doesn't change, so my final answer here is 0.125. And our last example, it says let E and F be events in a sample space S. Suppose E is 5/8, F is 3/8, and E or F naught is 0. Well, let's talk about this last part, E or F naught. So E or F, think about, would be everything in here. And then since it's wanting naught, or the opposite of that, we're really just looking at the margin, okay? So if that part is 0, that means that all 100% must be inside. So the question is, what's my overlap? And then let's break this apart into only E and only F. Well, if you take 5/8 and 3/8, that's 100%. So if that's the case and there's no overlap, we can go ahead and put 0 here. And answer the question. Part A says the probability of E given F By the way, there's a better way to draw this, really. It didn't tell us from the beginning of the problem, so we didn't know to draw it like this. But a better way to draw disjoint events like this, remember disjoint meaning they have no overlap, would just be to put no overlapping region. Okay, still put 0 on the outside. So E and F is 0, divide by, doesn't really matter. We'll go ahead and put 3/8, but it's not going to happen, okay? And the last one, it switches them, so we know that that happens as kind of formality, and then the bottom is this time E. But since you're dividing, the top is 0, the answer is actually the same. Okay, so with a given probability, it's not going to happen if they're disjoint. Go ahead and try day 1 from 3.2. If you have any questions, let me know. I will say this, I won't be able to answer questions too much today and maybe part of tomorrow because I'm undergoing a surgery. But all the videos should be done in advance and you shouldn't miss anything Wednesday or Friday. Thanks, take care, and if you have any questions, let me know. We'll see when I can respond.